Hey everyone, Linus here. Today we're diving into the world of cloud computing. You've probably heard the term thrown around a lot, and for good reason. It's revolutionizing how we use technology. Remember the days of storing everything on bulky hard drives? Those days are fading fast. Cloud computing is like having a giant virtual data center at your fingertips. It's changing the game for individuals and businesses alike. Cloud computing offers incredible convenience and scalability. Imagine accessing all your files and applications from any device, anywhere in the world. That's the power of the cloud. It's no longer a futuristic concept. It's here, it's now, and it's changing the way we live, work, and play. Buckle up as we explore this fascinating realm and discover what makes it tick. So, what exactly is cloud computing? In the simplest terms, it's like renting instead of owning. Imagine instead of buying and maintaining your own servers and software, you're essentially renting space on someone else's. This someone else is usually a tech giant like Amazon, Microsoft, or Google, who own and manage massive data centers around the globe. Think of it like electricity. You don't need to build your own power plant to enjoy the benefits of electricity in your home, right? You simply plug in and use it. Cloud computing is similar. You access computing resources, servers, storage, databases, software over the internet on demand. You only pay for what you use, making it a cost-effective solution for many. This image clearly illustrates the fundamental difference. On the left, we see the old way, storing data locally. On the right, the cloud represents a centralized hub where data is stored and accessed remotely. Let's peek under the hood to understand the magic behind cloud computing. At its core lies virtualization. It's like creating virtual versions of physical servers and their resources. Imagine dividing a powerful server into multiple smaller virtual servers, each capable of running its own operating system and applications. Pretty neat, right? These virtualized resources are then offered to users over the internet. Data centers play a crucial role here. These are massive facilities housing rows upon rows of servers, networking equipment, and storage systems, all working tirelessly to power the cloud. When you upload a file to the cloud, it's not just floating in the ether, it's physically stored on a server in one of these data centers. This image provides a glimpse into the physical infrastructure behind cloud computing. These data centers are marvels of engineering, designed for high performance, reliability, and security. Cloud computing isn't a one-size-fits-all solution. It offers a variety of services, each tailored to specific needs. Think of it as a digital toolkit, with different tools for different tasks. Let's break down the three main types of cloud services. First, we have IaaS, or Infrastructure as a Service. This is like renting the raw materials, virtual servers, storage, and networking to build your own IT infrastructure in the cloud. You have complete control over the operating system and applications, but you're also responsible for managing them. Next, there's PaaS, or Platform as a Service. This is like renting a pre-built workshop. You get the platform, tools, and environment to develop and deploy applications without worrying about the underlying infrastructure. It's like having a head start on your project. Finally, there's SaaS, or Software as a Service. This is like renting the finished product. You use software applications hosted by the cloud provider over the internet. Think email services like Gmail, video conferencing tools like Zoom, or customer relationship management software like Salesforce. This visual representation clearly differentiates the three service models, highlighting their respective levels of abstraction and user control. Section 5. Deployment models. Choosing the right fit. Now that we know the types of cloud services, let's talk about deployment models. It's all about choosing the right cloud environment for your specific needs. This is the most common model. The cloud infrastructure is owned and managed by a third-party provider, and resources are shared among multiple tenants. It's cost-effective and offers scalability, but it might not be suitable for sensitive data or applications requiring high levels of control. This is like having your own exclusive cloud. The infrastructure is dedicated solely to your organization, offering greater control and security. It could be hosted on premises or by a third-party provider. This is the best of both worlds. It combines public and private cloud environments, allowing you to leverage the strengths of each. For instance, you could use the public cloud for non-sensitive data and applications while keeping sensitive data securely stored in your private cloud. This visual aid helps to understand the differences in how data and applications are hosted and managed in each deployment model. Section 6. Cloud computing in action, real-world applications. Cloud computing is everywhere. It touches various aspects of our lives and powers countless applications we use daily. Let's explore some real-world examples. Cloud storage services like Google Drive, Dropbox, and iCloud have made it incredibly easy to store, access, and share files from anywhere. Cloud platforms like Amazon Web Services, AWS, and Microsoft Azure provide the infrastructure to host websites and applications, making them accessible to users worldwide. Section 7. The cybersecurity landscape, navigating the risks. While cloud computing offers numerous benefits, it also presents unique cybersecurity challenges. Let's face it, where there's valuable data, there will always be those who try to exploit it. Cloud providers handle vast amounts of sensitive data, making them prime targets for cyber criminals. Data breaches can lead to the exposure of personal information, financial records, and intellectual property, causing significant damage to individuals and organizations. Weak passwords, phishing attacks, and compromised credentials can give attackers unauthorized access to cloud accounts. This can lead to data theft, service disruption, and reputational damage. Malicious insiders with access to cloud environments can pose a significant risk. They may steal data, sabotage systems, or disrupt operations, often with devastating consequences. This image emphasizes the importance of robust cybersecurity measures to protect sensitive data stored in the cloud. Section 8. Staying safe in the cloud. Best practices. Don't worry, it's not all doom and gloom. While cybersecurity threats are real, there are ways to mitigate risks and stay safe in the cloud. Here are some best practices. Use strong, unique passwords for your cloud accounts and enable MFA whenever possible. This adds an extra layer of security, making it much harder for attackers to gain unauthorized access. Encrypting your data both in transit and at rest adds an extra layer of protection. Even if unauthorized access occurs, the encrypted data remains inaccessible without the decryption key. Cloud providers regularly release security updates and patches to address vulnerabilities. Ensure your systems and applications are always up to date to benefit from the latest security enhancements. Opt for well-established cloud providers with a strong track record of security and compliance. They invest heavily in security measures and have dedicated teams to monitor and respond to threats. This visual guide provides a quick reference for users to implement basic but effective security measures to protect their cloud data. Section 9. The future is cloudy trends and predictions. The cloud computing landscape is constantly evolving, with new trends and technologies emerging all the time. Here's a glimpse into the future of cloud computing. Imagine only paying for the actual computing time you use, down to the millisecond. Serverless computing eliminates the need to manage servers altogether, allowing developers to focus solely on writing and deploying code, bringing computation and data storage closer to the user. Edge computing reduces latency and improves performance for applications that require real-time processing, such as self-driving cars and remote surgery. While still in its early stages, quantum computing has the potential to revolutionize cloud computing. Its immense processing power could solve complex problems currently intractable for classical computers, opening up new frontiers in fields like drug discovery and materials science. This image encapsulates the transformative potential of cloud computing, hinting at a future where data is ubiquitous and seamlessly integrated into our lives. Section 10. Conclusion: embracing the cloud era. Cloud computing has come a long way since its humble beginnings. It has evolved from a niche technology to an indispensable part of our digital lives. From storing our photos and streaming our favorite shows to powering global businesses and enabling groundbreaking scientific research, the cloud has become ubiquitous. As with any transformative technology, it's essential to approach cloud computing with both enthusiasm and a healthy dose of caution. By understanding its capabilities, limitations, and associated risks, we can harness its power while safeguarding our data and privacy. The future is cloudy, and that's not a bad thing. It's a future filled with possibilities. And we're just scratching the surface of what cloud computing can achieve. This final image reinforces the message that cloud computing is no longer a distant concept, but an integral part of our daily lives, accessible at our fingertips.